Hello everyone. So last time we were talking about similarity. And similarity is when two figures, such as triangles, have the same angles and have sides that are proportionate. And the first method that we learned about in order to tell if two triangles are similar is called angle-angle similarity. And all this is saying is that if we have two pairs of congruent angles in two triangles. So for example, we have the angle B congruent with the angle E, and the angle A congruent with the angle D. And because the fact that those two angles are congruent, that means the two triangles ABC and DEF are similar, which means we know the following pair of proportions is true. That AB over DE is equal to AC over DF, which is equal to BC over EF. That's the key to similarity, that these sides are proportionate and the angles are equal. So, with that being said, let's try out this technique on our first problem. In the figure on the right, MN is parallel to OP. OP is 12, MO is 10, and LM is 5. Find MN. So, first thing I have to do is find out whether or not I have any pairs of similar triangles. Well, the two triangles I have are LNM and LPO. Are they similar? Well, based on the last theorem we talked about, let's look for some angles. And of course, since we see some parallel lines, that implies there must be some angles. So, this angle is congruent to this one. So I'm going to say that angle LNM is congruent to angle LPO. And that's because they're corresponding angles. That comes from those parallel line theorems. So, that is one pair of congruent angles in both triangles. Now, we could use the similar fact here, where we have another pair of corresponding angles. We could have also noted that they both share the angle L. Either one would have been fine, but I'm just going to say that angle LMN is congruent to angle LOP for the same reason as the first time. And now, because we have two angles that are the same in two pairs of triangles, or in a pair of triangles I should say, we have similarity, which means that triangle LMN is similar to triangle LOP. And notice the order in which I'm writing them. I wrote LMN. So if we look at this small triangle, let's start at L, then go to the M, which has the 2 tick marks, and then the N, which has the 1. And I wrote it in the same order with the other triangle. Start at L, go to the 2 tick marked angle O, and then go to the single tick marked angle P, because you want each corresponding angle to be in the correct position. So, now that we know that these two triangles are similar, we can create some proportions. Since we are trying to find MN, let's start with that. Well, what side does MN correspond with in the other triangle? Well, that would seem to be, since MN contains the two marked angles, in the triangle LOP, it would be the side with the other two marked angles, that being OP. So OP and MN are corresponding sides, and they are proportionate with the other sides. So we could start with, I don't know, LM And LM would be matching with LO in the larger triangle. And just be careful not to put MO, but the entire side LO. Now, notice I started with MN, which comes from the smaller triangle, and then on the denominator I put OP on from the bigger triangle. You have to do the same thing in your other ratio. LM is the smaller side of this is the side of the smaller triangle, and LO is the bigger side. And that is our last ratio we could write is LN and LP. Now, which one of these is going to help us solve for MN? Well, MN is our variable, so that's going to just stay that same. OP I can substitute with 12 since that's given to me in the problem. And that is equivalent to, well, let's just pick one of these two ratios, LM over LO or LN over LP. Well, LN over LP doesn't have any numbers associated with it. So that's not really going to help me solve for what I'm looking for. However, LM and LO definitely can be substituted with some numbers, like the fact that LM is 5 and LO, be careful, is 5 and 10, which is 15. Now, from there, we should see that, we could just multiply the 12 over, but I think it's handy to see that before we do that, 5 over 15 is simplified into 1 over 3. And that means when we finally multiply 12 on both sides, I'm going to multiply the 12 over here, we get MN equals 12 over 3, but that is just, of course, 4. So that is our answer. MN is equivalent to 4.